Okay, our next presentation is from Koji Oyama, who is a good friend of mine and also a very intelligent engineer. And he's going to be talking about some essentials for media over IP network design. Take it away, Koji.
Thank you, Wes. So, hello, everyone. My name is Koji from Xcelux Design, Japan. Today, I'm going to talk a little bit about essential for media over IP network design when you deploy a media over IP network. So today's agenda, first I introduce myself and I explain a brief of the media over IP. And then I explain the eight part of the essential technologies. And last conclude. So I have a multiple role. So sometimes I am a technical consultant and sometimes an evangelist and hardware software designer and founder of CEO of this company. And I love new technology. This is a basic of me. And my company, Xcelux Design, is Tokyo-based and founded in 2016. And I often, Tokyo-based, but I often come here, United States. I used to come here. Yeah, and so this visit is for the first time 2.5 years. So this presentation, so target is beginners of the network design. So broadcast engineer who are not familiar with IP network or IT network engineers who want to know what else is necessary to learn for MoIP network design. And the objective is so to make such broad engineers to obtain the basic knowledge that you need to design MoIP network. But as you know, the 30 minutes is not enough. So I will let you know the hint to learn the so fundamental technology. So maybe you already know or heard of it. So OSI model, hierarchical model of the protocol. So this is so typical. First essential so technology. So protocol is so structured so hierarchical, and the first so layer one of the so network is a physical layer, and it composed of the optical fiber cables or Kappa cables and optical transceiver modules. And Ethernet is on layer 2, and IP, Internet Protocol, is on layer 3, and TCP, UDP is on layer 4. So we usually use Ethernet and IP, and you can see the Ethernet switch, IP switch, but so you should take care of the difference. So layer 2, L2 switches are data transfer data by destination MAC address. And layer 3 switches I can transfer data by destination IP address. Different. And the media over IP transfers the video, audio data by using the IP protocols. And the multicast. So usually we use IPv4 multicast for the media. and unicast for the control. And also, we use IGMP when use the Multicast. So Multicast and IGMP is so pair of the protocol. And the other keyword is PIM, SSM, PIM-SSM, and IGMP3. So we will talk about later. And have you read the JTNM TR 1001 guideline? Yeah. So if you design a media over IP, so I recommend you to read it, because this is a basic and a guideline to design media over IP. And my presentation is also based on that guideline. And network is it recommend redundant network composed of the amber and blue network, and control network and media network is should be separated. This is a simple but very important thing. And this is this is an example of MoIP network based according to the JTNM guideline. And I designed a similar network, and it has grandmasters and L2 switches and L2, L3 switches, as well as the cameras, intercommunication equipment, video audio switches, and recorders, and player equipment. And PTP is come from the grandmaster and distributed to each media node. So yellow line, it means distribute each node. And switches is switches topology is a spine leaf. These two switches are spine switches. Here, this line switches are leaf switches. And the architecture is a spine leaf. And these switches is for media plane. And this lower side of the switches is a control for the control plane. It connects to the each equipment, and this case is two switches. We have two switches, and they connect to each other. And this is because the redundancy, but almost switches at this moment doesn't have two control ports. So maybe one port, or shared with the media port. But so this is ideal case. But so if you have both of the control ports, we make not only the logical but also the physical separate between the media plane and the control plane. This example. We design a separate, completely separate physically. And the network L2 and L3 switch. So we used to use a non-blocking switch, very high performance. and configurable. So maybe you you have bought affordable switches, but it's not configurable. Maybe just connect to the Ethernet and then maybe only L2 and use at home. But data center use switches is managed switches, and so we can put in the command and configure the functionality. And also, it's a resource shareable. So VLAN, VRF, I explain later. And redundancy and the speed and the cable, okay. And this is so one of the sample of the design flow, network design flow. So this is assumed, so system design is completed, and then so after that we design network. The first list all media and control equipment and count ports and the sessions to select network switches. And then define the design, the logical architecture, isolation, fault tolerance, and so then verify the design and iterate so sometime and finish the design. Different thing is compared with SDI-based network, we need to design logical, not only the physical, but also logical. It's a difference. And the configure network switches. So unfortunately, the command is different from each vendors. Yeah, and also the so each OSs. So now I design it by using the four switches. So I can run. I have to run the four command four languages. But maybe in the near future, SD controller can configure the upper side. So maybe we don't run at the situation. We don't run such a kind of script or commands. But now we have to run. And the next part is I will explain the 8 keywords: VLAN, VRF, Multicast routing, PIM, IGMP, OSPF, LACP, VRRP. First, so VLAN, maybe you know. So we sometimes use a VLAN. It's a virtual local area network. It's a technology to set virtual groups of devices and operate each as if they are one local area network. So diagram is a very simple to explain the VLAN. So if you have a completely different network, one and two, if you use a VLAN, you can combine and integrate the switches. But our left side and the right side is completely separated logically, not physically. Physically is the same, but logically is completely separated. And VRF, VRF, virtual routing and forwarding. This is similar as VLAN, but the layer is different. VLAN is on layer 2, but the VRF on the layer 3. So in this case, so L3, layer 3 network here by using the L3 network switches. Previous VLAN, so in that case, we use L2 switches. And completely different L3 network, but if you use VRF, we can combine, and but separated, completely different, completely separated logically. Physically, it's combined. So it means we can achieve the resource sharing and cost saving, and reduce our number of cable. And multicast routing is a method of transmitting to all subscribers registered in a group by one transmission. So this diagram is very so simple and easy to understand. Unicast is one-to-one. The broadcast is one-to-all. And multicast is one-to-many. And the Anycast is one-to-one of many. So multicast is this type of technology. And so often used for the media plane. And the protocol name is in this. So for the multicast protocols, we often use PIM, PIM, and the multicast VGP. Next is a PIM, protocol independent multicast. So this is used for the media plane, and there are 4 variants. And maybe you are heard of the PIM SSM. So the guideline recommend use to PIM SSM to connect L3 switches. And the next one is IGMP, Internet Group Management Protocol. It's a communication protocol used by hosts, and it allows the network to direct multicast transmission. So if you join, so hosts, I mean the receiver, want to join and they want to receive the data from sender. So first, the receiver have to join the multicast group by using the IGMP. So I want to join this group, and if it receive the OK of the IGMP protocol, so the data comes from the switches. And next one is OSPF. It's one of routing protocol for IP networks. This is used for the both media plane and the control plane. But I usually use for the media plane because if you if you make a very complex network, and so if you design a L3 network, you have to make a routing table for each switches. But if you have 100 switches, the so it's a very hard to configure because it's 100, right? So this case, compressed case, we use OSPF, and the OSPF is communicate neighbor routers and copy the routing table and make a new one by using the data from the OSPF. And the next one is LAG, Link Aggregation Group, and the LACP, Link Aggregation Control Protocol. Maybe it's used for the control plane. And if you make a redundant network of the control plane, it can be used. But media plane network is almost so similar and between the each vendors and but now control plane is so I think there is no best practice at this moment. So someone use the LAG, LACP, and someone use the other protocol. The LAG, LACP is it's for the combining multiple network connections in parallel by any of several methods. And the LACP is one of the protocol for the Ethernet. And if you host, maybe control plane, if you connect to the two, and one is one is dead, so it can be connect and communicate with the others. Next one is very similar to the LAG, VLAN. It's also used for the control plane. It provides for the automatic assignment of available IP routers to participating hosts. And it's same, similar. And the master, so if master is dead, so backup switches communicate with the host, media nodes. It can be used for the control plane and the control network. Okay. Anyway, how many keywords did you know? 5? Oh, good. And as I mentioned before, SDN controllers can configure network switches in the near future. But if you don't know these fundamental technologies, you never analyze any issue when your system doesn't work what you expect. So next step, I will explain the exists design cases, verification, network issues, debugging, Okay, maybe hopefully IVC time frame. And feel free to email me if you have a question. And also, if you want to join our Slack channel, so email me. Okay, that's it. Thank you.
Thank you, Koji-san. Thank you very much.